Okay, today we're going to be talking about adding an electronic way to do a walk, stop, walk action or dual function to your robot design. In this particular case, for this demonstration, I'm using the single TT motor mounted in the leg. You could do it with any sort of robot design that you've got going that has a motor driven thing that you want to have maybe just stop and wait and then go, or stop and turn on some lights, or stop and smoke, or stop and rotate a body, or whatever it is you want to do. So in this case I'm showing the function that happens when the legs stop walking, just as this gear motor. But I'm saying this gear motor could be replaced with lights, sound, smoke, whatever it is that you're after. Now in this particular case, if you've been following this single shaft meaning a motor with shaft only out one side, where I mounted the motor in the leg, and in the other leg I put in a battery holder for 2 AAA batteries. Because I'm going to be running electronics, I need to make sure that the 3 volts from those 2 AAA batteries is stable and clean. So I'm going to use this small buck converter, which can boost anything from 0.9 of a volt up to 5 volts. You don't want to put more than 5 in because it's going to put 5 out. You could damage it. But anything 5 volts or lower, as long as it's over 0.9 of a volt, it can boost up and give you a clean reference voltage. These come in different sizes. Some of them don't go all the way down to 0.9. Some will take you'll have to have at least 1.5 volts in. It's no problem. This is just a particular one that I found for this, to clean everything up. Then what I'm going to run is a simple 555 oscillator. 555 is a chip that's been around since the 1970s, early 1970s. And it'll reliably operate as low as 4.5 volts. You can actually get them to work lower, and that's just not always reliable. So this little 5 volt booster coming off of the 3 volts from here is a good way to clean that up and give me a nice clean 5 volts to run the timer. Now, it's cheaper to buy complete 555 timing modules like this thing than it is to buy the parts. You buy the chip, you're going to need a couple of resistors, you're going to need a timing capacitor, you're going to need a filter capacitor, and if you want to be able to adjust the duty cycle and the frequency, you're going to need some trim pots. You can get these whole modules for about $1.19, $1.20, something like that. Well, you can pay more, of course, but I mean, if you shop around, you can get them for that low. And you basically just have your 5 volt in and ground in the middle, and then your output pin here. And by adjusting the duty cycle, you can get it pretty much where it'll be half the time it'll be on, half the time it'll be off, and then you can adjust the speed. This particular one has a jumper, and depending on where you put the jumper, if I lift it off there and put it onto here or put it onto there, it has different timing functions. Now this is the slowest this one will go, which is only about 1 second. And I wanted to go slower than that, so I ended up adding another timing capacitor. This jumper is basically tying in different timing capacitors, little teeny surface mount capacitors there. Well, this one big one, and I guess they did it because they were already using the same value over here as a filter cap, is for the 1 second timing. And so basically by lifting that jumper off and soldering a new cap across the 2 pins that are on there and then bringing it over to the ground lug, I could slow it down even more. So that's what I ended up doing. I think I used another 470 UF capacitor on the one that's down here, and I'll show you a close-up of that in a second. But I wanted to get it to where I had about 5 or 6 seconds of walking time, and then by using the symmetry control, I wanted to have 3 or 4 seconds of pause, not walking, which could be, like I said, another function. It might be arms moving, it might be gears in the chest, it might be a smoker, it could be lights, whatever. Now, to actually control the motors, you're going to need some sort of driver, and you can just do it with simple FETs, but again, it's a lot cheaper, it's less expensive just to buy one of these devices. And this is a dual H bridge. The dual part means that this one chip can actually control two different loads, in this case 2 different motors. I'm using one of the H bridges on here to control the leg walking, and the other one on here just to control this motor sitting out here so you can see the other function. And you've got control pins in, and there's a truth table for these because there's 2 pins for each one. An H bridge gives you the capability of not only turning a motor on or off, but you can also make it run one direction or reverse the other direction. We're talking about DC brush motors in this case. And there's 2 of them on there, so each one can do that. But that means there's a truth table for the input connections, meaning if nothing's connected to these at all, they have resistors built in, and it's considered a low state. So anything that you wanted low, you can just leave open, and you can bring your other control into the other one. I'll show you the truth table coming up. In reality, since there's no body on here yet and this thing is so wide, I think if I was going to build a robot, and I'm going to, I just haven't decided what yet, I would go ahead and go with a larger battery pack in the back of the body like most standard toy robots had, going with either 3 or even 4 AA batteries, which would give you a longer runtime. It would give me the higher voltage, so I wouldn't even need to use this buck converter to boost it up to 5. I could just run off the batteries. They'd get you down to just having the 5.5 timer and the H bridge, 2 simple components. And if I was going to do that, put the batteries up in the body, then I would just print, in this case for this project, I would print a new right leg that doesn't have the battery door and doesn't have the battery hatch. So those are transformations that'll probably happen to this as I figure out exactly what functions I want to put in there. So but right now I wanted to show you some of the information on these chips that you can find online. And I realize we're not completely straight on in this picture, but we're pretty close. So this is showing you the 555 timer circuit that I showed you, the jumpers. They're telling you which jumper you put in. If you put it in that position, go between 1 Hertz and 50 Hertz by using your frequency control, your speed control. And this is your duty cycle one over here. I mean, it can go all the way up to 200,000 cycles per second. But anyway, we're going to go with the slower one, and just simply, and this is the slower one's timing cap, add another cap. So when I bring another cap in, actually just moved this bridge up to here to get it out of the way, but to save it, I'm going to solder across those 2 pins with the positive lead of my new capacitor. I think I used a 470 microfarad, and the ground one I'll just bring over to ground. And in that way, I can get, by using this frequency control, I can go as long as like 10 seconds or so walking time, and then 10 seconds of pause, if you will, or 10 seconds of the second function happening. And it gives you some of the information on there. There is an LED on the board that shows the state of the output pin. The LED lights when the output pin on the 555 is low, because the 555 actually drives its most current on the low side, which isn't important in this function because our H bridge that we're connecting to has sensitive inputs. This is the truth table for the H bridge, which is here. So you can see this is what I was showing you, and they're showing you a motor connected up here and a motor connected up here. So if you looked at each one individually, you can go, you've got your 2 inputs, and depending upon the truth table that you follow, let's go back to the truth table. Here's your motor A, motor B, so you can just look at one of them. If you wanted the motor off, standby, you would just leave both those inputs low. You don't have to do anything to them. If you wanted to make the motor run in one direction, you can make input 1 high and just leave input 2 alone, and the motor would run in one direction. If you wanted to reverse direction, you'd leave this one low and make that one high. So in my case, what I'm actually going to do is I'm going to tie input 1 on one of the controls to V plus all the time. And let's take a look at it here. I don't guess I can put it up into the camera. I'll just have to explain it verbally. I'm going to take input 1 and tie it to the V plus to the chip. I'm going to take input 2 and bring it down and tie it to the input 2 of the B1. Well, actually to the input 1 of the B1. So they're right next to each other, like that. And that's the one I'm going to bring the signal into from the 555. And I'll leave the other input on input 2 alone, just leave it low. And what that'll allow me to do is to have when one motor's turned on from that single 555 output going high or low, turning one on or turning it off, and at the same time flip-flopping the other one, turning it on, turning it off, just back and forth. So that is what we have there. When you initially turn them on, the run cycle is going to be longer initially till the capacitors charge up. And let's watch for that LED on this little board. There we go. So when that LED's on, your second function is running, and the LED's off, the legs are walking. And then on. So there you have it. If it's something you want to experiment with, you can find these types of devices online. For example, if you're looking for one of these, you're going to put in things like 5-volt boost regulator, for example, would be some terminology that's commonly used for these little things. Like say $1 or less when you buy these in small quantities. This is a DC motor H-bridge, dual H-bridge driver. Very inexpensive. This is a 555. Sometimes they just call them an oscillator. Sometimes they call them a function generator. Sometimes they'll call it a square wave generator. Some of them don't give you both controls. Some of them don't give you these timing options. Some of them are much simpler. In other words, this is going to be the chip, maybe a single frequency pot, and the in and out. I picked this one after looking at all of them because it was so inexpensive and it had so many more variables. I wanted to be able to control the duty cycle because I might want the upper function, in my case, whatever I decide to do above the body when it's not walking, run at a different duration than the walking. So I was thinking 5 or 6 seconds of walking and then maybe 3 or 4 seconds of whatever I do with the second function.